So if you're like me growing up as a kid, I would hear about, ooh, India is having a difficult monsoon. A monsoon event is happening in some part of the world. Maybe you didn't know India. But as it turns out, only after we have talked about these large circulation cells within the Earth's atmosphere, the Hadley, the Ferrel, and the polar cell in each hemisphere, can we talk about monsoons. And India's notorious monsoons, getting drenched in rain with their monsoon, in what we call a monsoon, actually they have a counterpart to the wet monsoon season. There is a dry monsoon season for India too. And so the thing that's in common with a location like India, and we're going to talk about a location in North America actually that has a type of monsoon season, is that the thing that's in common is this wandering location of these major circulation cells. And so I'm going to show that to you, but if anybody asks, India has a dry and a wet monsoon season, and it's caused by this wandering intertropical convergence zone. So I'll let you kind of take a look at the text that's associated with this figure, but I do want to focus on India at first. And in Chapter 7, one of the things we looked at on an earlier slide was focusing in on the intertropical convergence zone. Okay, this line, this purple here, is where the trade winds converge. And here you can see the northeasterly trades. Let me change it to blue. Here's the northeasterly trades, and here are the southeasterly trades converging. And in July, or I guess July, because there's a little bit of a lag. Even though June is the summer solstice, July is usually when we have the hottest temperatures. There's where the intertropical convergence zone is. So what's significant with India are the Himalayan mountains. Let me choose a different color. Let's go with, I guess, red. I can choose different colors. This is Explain Everything is a great app. Let me put a little plug there. So there are the Himalayan mountains. Now, one of the things we talked about earlier in this course, not in Chapter 7, but is this mechanism called orographic lifting. And so the Himalayan mountains are great at basically when those southeasterly trade winds pick up that moist air from the Indian Ocean. They are orographically lifted, the Himalayan mountains, and they can go ahead and once they're lifted, that the water vapor can condense, and we can go ahead and get a bunch of precipitation here. Okay, so that's why in the summertime, these folks here on I guess it would be the windward side of the Himalayan mountains, have monsoon season. It's wet. Now I'm going to contrast that here in a minute, 6 months later, as the next slide. Okay, here's 6 months later. I'll let you kind of take a look at the text over there. The text will explain that the intertropical convergence zone has moved. Let me go ahead and zoom in on this figure now. So this would be in January, thereabouts. And notice that here's our intertropical convergence zone down here, that purple line, and it has moved a lot. So here are Himalayan mountains, okay? And one of the things we talked about, of course, what bumps up against the intertropical convergence zone, let me choose a different color. Okay, there's blue, is the Hadley cell. I'll go ahead and put Hadley. I don't know if this will all show up on I guess it will. There's the Hadley cell over here, and we said that, of course, you can see these northeasterly trade winds converging here with the southeasterly trade winds, the intertropical convergence zone. It's going to wander, right? And then the other thing I want to point out is that at the top of the Hadley cell, where the Hadley bumps up with the Ferrel, we have these semi-permanent high pressures. And actually, one of the things we know about high pressures is that we have descending air and we have clear skies. So basically, remember where the Hadley and the Ferrel bump up, we sometimes have our deserts. And so now we have this dry air that is bumping up against the Himalayas. We may have orographic lifting, but there's no moisture there. So, and then notice here then, our winds have totally changed. So if you're here, you don't have the benefit of warm, moist air coming from the Indian Ocean to slam up against the Himalayas. Basically, now you are on the leeward side of the prevailing wind, and this is a dry season here in India. So I just think that this is so cool. Now I'm going to contrast. This is. Do you see how this the monsoon seasons are here dry in the winter, and earlier in the summer were wet for one location, and it's all related to the wandering intertropical convergence zone. Now I'm going to show you the monsoon season in southwest North America, and it's a little more subtle to me. See what you think. So, as I mentioned, this seems a little more, the North American monsoon seasons seem a little more elusive to me. And if you're like me, I'm a Googler. So I went out and actually Googled North America monsoon, and there are things out there about how people in these affected areas are very conscientious about in the summer through September, as this slide says, this region can really get excess rain. Versus other times of the year. And I think I misspoke because as I look at this again, it's not really this monsoon season in North America, I'm going to show you, is not associated with the wandering intertropical convergence zone, but it is seasonal, and it has to do actually with the continent here I'm going to show you actually gets warms up more quickly than the large bodies of water, in this case the Pacific Ocean, maybe the Gulf of Mexico, and this warm continent then has a generally a kind of low pressure. And what we know about low pressures is that air is going to move from the surrounding moist air from the Pacific and the Gulf are going to kind of move in and converge on that continent. So let me show you that on the next figure. So this is what I was talking about, and let me just go ahead and kind of zoom in on this one. Hopefully you can kind of make that out. In the summertime, basically you have the Pacific Ocean here and the Gulf of Mexico here, and these large bodies of water are stubborn to heat up. So what's going to heat up more quickly is the land, and more specifically, can you see where this is not just the land, but this is also kind of mountainous, kind of, I don't know, maybe not the dead of the mountain, but anyway, this is warmer. Okay, I'll just go ahead and put warm here. And so we generally have kind of a low pressure at this time of year. And one of the things we know, we've been talking about it quite a bit, is that air will move from a high, relatively speaking, into, those are H's for high pressure to a low pressure. And so we have kind of this movement of air here, and that converging air, let me change my color just because I can, that converging air is going to go ahead and be lifted up. And so again, a theme that we've talked about in an earlier chapter is that lifting air raises all boats. No, lifting air will go ahead and expand, and as it expands, it will cool. And if there's moisture, if there's vapor in the air, it will cool to the condensation, to the point of condensing, and so you'll get clouds and maybe even precipitation. So let me go ahead and move over just a little bit. So that would be a lot of precipitation then in the summertime. And like the previous slide says, kind of peters out maybe about September. So this is what we call a climatic gram, and we're going to be talking, climatic grams are great for looking at, we looked at climatic grams before when we talked about factors influencing climate. So let me see, highlight a few things. This is for Tucson, Arizona, that is affected by the monsoon seasons in North America. And so here we see June, July, and I'm highlighting down here, these are bars that are showing you precipitation. So the way you read this is over here on the right, you see centimeters, or in parentheses, inches of precipitation. So here we have 2 inches of precipitation, But just look how tall that bar is compared to, that's July, compared to June, May, April, March, etc. So this would be the dry season here. This would be the wet season here. So there you go. Let me zoom out one more time. Okay, so I hope that you're convinced that it's not because of the movement of the major features of circulation cells per se, but it is definitely seasonal, and that's why we call it a monsoon seasons. The monsoon is always a pair of seasons.